Hey everyone, and welcome back to the AI Research Roundup. I'm your host Alex, and today we're diving into some interesting work on training large language models. We're looking at a paper titled A Minimalist Approach to LLM Reasoning, From Rejection Sampling to Reinforce. Basically, the researchers took a close look at how reinforcement learning is used to fine-tune LLMs for complex reasoning tasks. They found that a really simple method, just training on positively rewarded examples, actually performs surprisingly well, sometimes even better than more complex methods. They also propose a new lightweight approach called Reinforce Reg. Okay, so let's look at some results in Table 1. This table shows the performance, specifically the average accuracy of different algorithms on several math benchmarks using two different base models. What's really striking is how well RAFT performs. For the QN model, RAFT gets 49.9% average accuracy, which is better than iterative DPO and close to PPO. And RAFT++, which adds importance sampling, gets 52.5%, very near GRPO's 53.9%. We see a similar pattern with the Llama model too. It really shows these simpler methods hold their own. Okay, so Figure 1 gives us a closer look at how these models learn over time. It shows the average accuracy on the y-axis plotted against the number of training steps on the x-axis, specifically for the RAFT and RAFT++ algorithms. We see two plots, one for the QN model on the left and one for Llama on the right. The solid lines show RAFT and RAFT++ improving as training progresses, with RAFT++ generally learning faster and reaching higher accuracy. Those dashed lines represent the best performance achieved by the other methods, like GRPO and PPO, which we saw in the table earlier. Just for comparison. Okay, now, Figure 2 gives us some additional insights. Similar to Figure 1, it shows performance over training steps. But here, on the left plot for the QN model, we're looking at the training reward curves instead of just accuracy. It compares RAFT, RAFT++, and GRPO again, but also adds a line for RAFT++ without clipping, showing how that specific component helps. Then, on the right plot for the Llama model, it shows both the reward curve and something new, the entropy loss on a second y-axis. This plot compares standard RAFT++ with a modified version using a trick called clip higher, and we can see how that impacts not just the reward, but also the entropy loss over time. Okay, building on that, Figure 3 gives us another angle on the learning dynamics for RAFT++ and GRPO. Like before, we see plots for both the QN and Llama models. What's new here is that alongside the accuracy curves, which we've seen improve, we're also looking at the KL loss on the left plots, and the entropy loss again on the right plots. This lets us compare how these two algorithms, RAFT++ and GRPO, behave not just in terms of final accuracy, but also in how much the policy changes, that's the KL loss, and how diverse its predictions are, that's the entropy loss, during training. Okay, going further, Figure 4 digs into some ablation studies, basically testing different components of these algorithms, specifically using the Llama model. The top row of plots shows the reward, KL loss, and entropy loss again, like we saw in Figure 3, but this time for several modified versions of the reinforce algorithm. Things like removing prompts where all samples were wrong, or removing prompts where all samples were correct, and adding different kinds of normalization. Then the bottom row compares GRPO, RAFT++, and vanilla reinforce, but also adds the new proposed method, Reinforce Reg, again looking at reward, KL loss, and entropy loss. This helps isolate what really makes GRPO work well. So, wrapping up after those detailed comparisons, this paper really highlights how we can get strong LLM reasoning using surprisingly minimalist reinforcement learning techniques, building on ideas like rejection sampling and simpler reinforce variants. It suggests simpler methods can be quite effective. This is important work because it helps refine our approaches for boosting LLM reasoning. Well, that's all for this week's AI Research Roundup. Thanks for tuning in. I'm Alex.